Quadratic equations, completing the square. Recall in this module, we have been looking at several methods for solving quadratic equations. That is, equations that can be written in the form ax squared plus bx plus c equals 0. Equations where the highest power or the degree is 2. Now we've already looked at factoring and the square root property. In this topic, we take a look at the method called completing the square. Now, completing the square is an algebraic technique that transforms any quadratic equation into an equation of the form q squared equals k. And recall, when you get an equation into the form q squared equals k, you can then apply the square root property. So that will be our goal. Now, note, the factoring method and the square root property, which we've already discussed, each allow us to solve some quadratic equations. However, once we master the technique of completing the square, it will allow us to solve all quadratic equations, any quadratic equation that is given to us. To begin, the key to understanding completing the square is to first understand perfect square trinomials, and that's where we begin our discussion. Let's start with a definition. A perfect square trinomial is a three-term polynomial that can be factored into a binomial squared. For example, here are two perfect square trinomials, x squared plus 6x plus 9 and x squared minus 10x plus 25. Now, what makes them a perfect square trinomial is that they can be factored as the square of a binomial. Notice x squared plus 6x plus 9 factors as x plus 3 times x plus 3, which we can write as the binomial x plus 3 quantity squared. It's a binomial times itself. X squared minus 10x plus 25 likewise can be factored as x minus 5 times x minus 5, which is simply the quantity x minus 5 squared. Now, how do you recognize perfect square trinomials? What you do is you notice that the last term in your trinomial is a perfect square. 9 is the perfect square of 3. 25 is the square of 5. The middle term is twice then that number that's being squared. The number which when squared gives you 9 is 3. And if you double 3, you get 6. Likewise, the number which when squared gives you 25 is 5. And when you double 5, you get 10. Let's see if we can create a perfect square trinomial. Let's start with x squared. And let's put a perfect square at the end. How about 64? 64 is 8 times 8. What's twice 8 or the double of 8? Well, that would be 16, and let's make everything positive. So then our middle term would be 16x. And how would this factor? This would factor simply as x plus 8 times x plus 8. Which we could also write as x plus 8, the binomial squared, x plus 8 squared. Do you see the pattern? Let's now take a closer look at perfect square trinomials. Let's make an observation. Any binomial of the form x squared plus bx can be transformed into a perfect square trinomial by adding the appropriate number, which will be a perfect square. For example, let's fill in the blank with the appropriate number to transform the binomial of the form x squared plus bx into a perfect square trinomial. That is, we want to take x squared plus 12x and add to it a number so that this polynomial will factor as the binomial square, x plus 6 quantity squared. Now, there's a couple ways we can determine what goes in the blank. One way is to look at the right side, expand it out, and that will tell us what we need to put in the blank. If we were to start with x plus 6 and square it, that would be equal to x plus 6 times x plus 6, which when multiplied out gives us x squared plus 12x plus 36. So it's clear that the number in the blank has to be 36. An alternative way to look at that would be to think about the examples that we just looked at. In our examples, we looked at a polynomial on the left, and we noticed that this number here was a perfect square of some number. And this was twice that number, which when squared gave you this number. What am I talking about? In other words, if we were to take half of this number here, which is half of 12, we get 6. And 6 squared gives us 36. That's the relationship that will help us create these perfect square trinomials. Let me restate. There's an important relationship between a perfect square trinomial and its factored form that should be recognized here. If you have a polynomial, a perfect square trinomial that is, x squared plus 12x plus 36, and it's factored as a binomial square, then the number which is inside your quantity, 6, will also happen to be half of the middle coefficient. Not only that, but the end term will be the square of that number. 6 is our magic number because half of 12 is 6, and 6 times 6, or 6 squared, gives us 36. Pay careful attention to this relationship. This is the key to completing the square. Let's further explore the idea of creating perfect square trinomials. Example. Fill in the blanks with two different numbers to transform the binomial of the form x squared plus bx into a perfect square trinomial. In other words, a trinomial that factors as a binomial square. Here we look at x squared minus 18x plus blank equals x plus blank squared. We begin by noticing that b, our middle coefficient, is negative 18. And we can fill in the blue blank over here. This number over here, remember, is half of negative 18. Half of negative 18 is negative 9. And so negative 9 is what completes our binomial being squared. That is 8x squared minus 18x plus blank equals x minus 9 squared. Now, what would go in the blank? Again, we refer to this number, negative 9, which is half of negative 18. And negative 9 squared is what goes in the blank. Negative 9 times negative 9 is 81. And therefore, that means our perfect square trinomial is simply x squared minus 18x plus 81, which factors, and you can check, as the binomial x minus 9 quantity squared. The key to completing the square is being able to turn trinomials into perfect squares. So we finish with two last examples. Example A. Let's find the last term to make this trinomial into a perfect square. In other words, we have x squared minus 14x plus blank. And we want to turn it into a quantity being squared. How do we do that? In order to turn a trinomial into a perfect square, we want to focus on the middle coefficient, b. In this case, negative 14. And we're going to take negative 14 and we're going to take half of negative 14. Half of negative 14 is negative 7. If I'm rewriting this as something being squared, the negative 7 is crucial to this binomial. But it's also crucial to the trinomial. How? Well, what goes in the box to make this trinomial is simply this number, negative 7, squared, the square of that number. And negative 7 squared is 49. So what we put in the box right here is positive 49. x squared minus 14x plus 49 will factor as a perfect square. In fact, when this polynomial is factored, it becomes the quantity x. Then we take this special number right here, right, the negative 7, and that's what we use in this parentheses. So we have x minus 7 quantity squared. We have taken a trinomial and we've rewritten it as a binomial square. We can check it by taking x minus 7 squared, which is just x minus 7 times x minus 7. And when you distribute or FOIL it out by multiplication, you would get x squared minus 14x plus 49, which is our trinomial. Let's take a look at one last example where we take and create a trinomial that will factor as a perfect square. We finish with one last example where we create a trinomial that can be factored into a perfect square. Let's take x squared plus 9x plus blank. And our goal is to factor this as x plus something quantity squared. First, we have to determine what would be the third term in this trinomial. To do that, we look at the middle coefficient. Our middle coefficient, or b value, is 9. And our procedure says take 9 and take half of it. Half of 9 is simply 9 halves. This is the special number that's going to go into our binomial that's being squared. But what goes in the box, recall, is simply this number, this special number that we just got, 9 halves, squared. Oh yuck, it's a fraction. No worries though. Top 9 squared is 81. 2 squared is 4. So the number that would make this polynomial into a trinomial that can be factored as a perfect square is 81/4. And to factor this, we would have x plus this number here, our special number, 9 halves squared. And if we multiplied this out, we would discover that this would give us x squared plus 9x plus 81/4. This step of turning a polynomial into a trinomial that can be factored as a perfect square is the critical step when we use the process of completing the square to solve quadratic equations.